NASA's long-armed Phoenix headed for May 25th landing on Mars. With a planned arrival at Mars on May 25th, NASA's Phoenix Mars lander will end a long journey and start a 3-month mission that will analyze fistfuls of soil and buried ice. But it's the entry, descent, and landing, or EDL, that is seizing the focus of Phoenix team members as landing day nears. For more information, log on to www.nasa.gov/Phoenix.
The main purpose of EDL is to take a spacecraft that is traveling at 12,500 miles an hour relative to the surface and bring it to a screeching halt in a soft way in a very short amount of time. So all that energy we put into a spacecraft to heave it off of Earth and take it somewhere else, we then have to take all that back out very quickly in order to gently set this thing down on the surface of another planet.
The discovery of ice surrounding the permanent polar caps was made February 2002. Odyssey spacecraft had the ability, using gamma rays and neutrons, to actually see through the surface down to about a meter depth, and they found an abundance of ice surrounding the known polar cap in places where ice had never been seen in the summer months. And so this was a huge discovery, and to me it represented an opportunity. One, to understand the ice that is under the surface of Mars, and two, to try and understand if perhaps this is a habitable zone. This is part of the goal, and we make those steps, finding water and finding a habitable zone in the search for life on Mars. And we may not find life on Mars, but we certainly will try and do those first two.
Phoenix is looking for habitats on Mars, places where life could exist or could have existed in the past. We know that life needs three things to exist. It needs an energy source, like sunlight, it needs water, and it needs organic molecules. That's molecules that contain carbon, oxygen, hydrogen.
Atmospheric entry on my mark. 5, 4, 3, 2, 1, mark.
We have now entered the atmosphere and are starting to slow down.
Phoenix now 1 minute past the entry point. We still have a signal via Odyssey. At this point in time, Phoenix goes normally through peak heating. At this time, we still see a signal via Odyssey. Standing by for Odyssey switch to 32K in 45 seconds. Stop of Odyssey canister data and switch to 32K in 10 seconds. Odyssey switch to 32K detected. We have Odyssey locked up on the Phoenix carrier. Standing by for expected parachute deployment and Phoenix switch to 32K. At this point in time, Phoenix would have normally deployed its parachute, standing by for telemetry acquisition. Phoenix switch to 32K detected. We have data lockup, parachute deployment trigger detected, heat shield trigger detected, ground relative velocity 90 meters per second. Ground relative velocity 80 meters per second. At this point in time, standing by for radar RF on and altitude convergence. Radar switch to altitude mode. Standing by for altitude convergence. Land leg deployment trigger detected. Ground relative velocity 60 meters per second. Standing by for altitude convergence. Radar reliable. Altitude 2,000 meters. Altitude convergence detected. Altitude 1,800 meters, 1,700 meters, 1,600 meters. Standing by for landed separation. Altitude 1,100 meters. Signal may drop out during landed separation. Altitude 1,000 meters. The separation detected. We have reacquired the signal. Gravity turn detected. Altitude 600 meters, 500 meters. 400 meters, 250 meters, 150 meters, 100 meters, 80 meters, 50 meters. Constant velocity phase detected. Altitude 40 meters, 30 meters, 27 meters, 20 meters, 50 meters. Standing by for touchdown. Touchdown signal detected. Landing sequence initiated. Helium vent detected. Standing by for normal termination of EDL comm.
Camera on Mars orbiter snaps Phoenix during landing. A telescopic camera in orbit around Mars caught a view of NASA's Phoenix Mars lander suspended from its parachute during the lander's successful arrival at the northern polar region of Mars Sunday evening, May 25th. The image was taken by the HiRISE camera on NASA's Mars Reconnaissance Orbiter. For more information, log on to www.nasa.gov/Phoenix.
I wasn't worried about it. I had no technical objection to taking the image. I was skeptical that they would be able to get it, and I am amazed. I will never be a skeptic on certain individuals again.
When you look at some of those up-close troughs, you actually see what looks like freshly dug depressions in the center of them, and this is just like the active surfaces you see in the Arctic regions on Earth. So it implies that we have an active surface. In other words, the ice is still there and expanding and contracting with the seasons.
400 meters, 250 meters, 150 meters, 100 meters, 80 meters, 50 meters. Constant velocity phase detected. Altitude 40 meters, 30 meters, 27 meters, 20 meters, 50 meters, standing by for touchdown. Touchdown signal detected. Landing it sequence initiated. Helium vent detected. Standing by for normal termination of EDL comm. Standing by for normal termination of EDL comm.
Phoenix Mars Lander. Some of the latest images from the Phoenix Mars Lander, taken of the Martian polar surface. The first ever pictures taken of the region from the surface of the red planet. Also includes images taken of the lander by the Mars Reconnaissance Orbiter. Phoenix will spend 3 months studying water, the potential for microbial life, and weather at Mars's polar region. For more information, log on to www.nasa.gov/Phoenix. disappearing ice. These images were acquired by NASA's Phoenix Mars lander's surface stereo imager on the 21st and 25th days of the mission, or SOLS 20 and 24, which are June 15th and 18th, 2008. These images show sublimation of ice in the trench informally called Dodo Goldilocks over the course of 4 days. In the lower left corner, lumps disappear, similar to the process of evaporation. For more information, log on to www.nasa.gov/Phoenix. NASA Science Update. Excerpts from a NASA Science Update on the Phoenix Mars lander, June 26th. The briefing was held on the National Mall in Washington, D.C. at the site of the annual Smithsonian Folklife Festival. For more information, log on to www.nasa.gov/Phoenix.
Phoenix is a perfect example how much the existing missions, such as Odyssey, such as the Mars Reconnaissance Orbiter, came to provide us the exact landing site and to provide us the communications. And this is one more step in our step in trying to understand water. And water is one of the threads of life.
My gosh, here's a chance to land a spacecraft with an arm and scoop up some of this icy soil and for the first time really investigate Martian water. Why Martian water? Because water is the root of all life on Earth, and perhaps the same is true on Mars. So if you're looking for life on Mars, or anywhere else in the solar system for that matter, first you need to find water. Water is the holy grail of planetary exploration. It's so common on the Earth, we forget that it's very rare in other places, but I live in the desert. If you go out for a hike without water, you're in trouble. So here we are. We can land in a place on Mars that has ice right near the surface, and we can find out about its properties, particularly if it's ever melted.
Of ice. And we want to understand what happened in that planet.
Gentle wind. And then our temperatures are from -22 Fahrenheit, inches in the sky, and the colors represent more or less dust, basically.
So you see a soil and the ice on the surface might look, actually look
Inches from the surface. So sweeping with a broom would just clean that right.
Good afternoon and welcome to a special NASA Science Update from Washington, D.C. We're here today broadcasting from the Smithsonian's Folklife Festival on the National Mall.
Phoenix returns treasure trove for science. NASA's Phoenix Mars lander performed its first wet chemistry experiment on Martian soil flawlessly, returning a wealth of data that for Phoenix scientists was like winning the lottery. For more information, log on to www.nasa.gov/Phoenix. NASA's Phoenix Mars lander rasps frozen layer, collects sample. A powered rasp on the back of the robotic arm scoop of NASA's Phoenix Mars lander successfully drilled into the frozen soil and loosened material that was collected in the lander scoop. Images and data sent from Phoenix early Wednesday indicated the shaved material in the scoop had changed slightly over time during the hours after it was collected. For more information, log on to www.nasa.gov/Phoenix. NASA Mars Phoenix mission success panorama. This view of the Martian real estate surrounding NASA's Mars Phoenix lander is the first complete 360-degree high-resolution color view around the spacecraft. The panorama is referred to as the Mission Success Panorama because the view around the lander satisfies one of the mission success criteria. Phoenix landed on May 25, 2008 in the North Arctic plains of Mars. For more information, log on to www.nasa.gov/Phoenix.
We call this 360 panorama our Mission Success Pan because we had a number of criteria set out for the Phoenix team to ensure that we've accomplished our goals. And one of the items for the goals were to get a 360-degree, three-color panorama all the way around the lander. Now that the team has acquired the three-color, three-filter 360-degree panorama. The team is making plans to acquire the same 360 degrees, but in 15 colors or 15 filters. What that gives us is a lot of chemistry information about the environment around us. We'll understand more about the reflectivity in different colors of the spectrum. In addition to seeing all the way around the lander, this panorama also gives us color of our workspace, which is where the robotic arm has been digging the trenches. This panorama shows where all of the dig spaces are and the depth of these trenches.